Good morning, dear students. Today we'll start uniform circular motion. So in the previous classes we have covered uniform motion, what is uniform motion, what is non-uniform motion and all that. So today we'll cover uniform circular motion. So what is a circle? As you know that this is a circle. Roughly I am drawing the diagram. This is a circle. If a body is moving in this circular path with same speed or same velocity, then its motion is known as uniform circular motion. For example, if I give you an example, suppose this is a rectangular path. Let me name it as A, B, C, then D. Suppose an athlete or a body will start running from position A to B, then C, then D. Suppose a person is riding a bicycle or riding a bike from point A to point B, and from point A to point B he can go or she can go with the same speed or same velocity. Why? Because this is a straight line. Now while turning at point B, while turning he has to apply brake. Okay, you might have observed this in practically. Suppose this is a road, you are riding a bike or you are riding scooty, you can ride your bike or scooty with full speed in this direction. But when these paths come, when you want to change the direction, you cannot go with the same speed. You have to apply brake, then you need to turn, then you will accelerate. Okay, this is how you will move. You will change your direction and you will move. Same thing happens here. From A to B, there is certain speed. At point B, the person or the body has to decrease its speed or velocity. Then it has to turn. Then from B to C, again it has to move. Then at point C, it has to turn. So it has to reduce its speed or velocity. So these things goes on in this rectangular path. But in case of circular path, the body can move with the same speed. Okay. In circular path, the body can move with the same speed. It doesn't have to change its direction. Okay, it doesn't have to change its speed. But in this case, the body is moving with the same speed but different direction. In a circular path, the body can move with same speed but with different direction. How direction changes here? Let me explain you. Let me draw the circle again. Suppose this is a circular path. Here randomly I am taking some point. This is point number 1. This is point number 2. This one is point number 3. Okay, see in three different paths. Here the direction of motion of the body is like this. The body is moving in this direction. Here the direction of motion of the body is from here to here like this direction. Here the direction of motion of the body is like this. Here in first case the body is going in upward direction. From here to here the body will moving in the upward direction. Upward. From here to here the body is moving in the west direction. Here to here the body is moving in the south direction. So upward, that is here in case of this one is northeast direction, this is northwest direction, this is south direction. So direction changes. If you take another point here suppose This is, suppose this is point number 4. So here the direction of the body is like this. The body is moving in this direction. So at different points, the body will have different direction, although the speed or the velocity of the body remains constant. So this is the concept of uniform circular motion. Object does not change its magnitude. Magnitude means the value of the speed or velocity. In case of here, object does not change its magnitude or velocity, but only its direction of motion. Here, the speed of the body remains constant, but the direction always changes. Suppose at this point the body is moving with a speed of or a velocity of 40 km per hour, then from point 1 to point 2, then point 3, then point 4 to point 1. This entire circle, the body can move with the same speed, that is 40 km per hour. But each and every single point, the direction of the body changes. Okay. So here it is. If a body moves with a velocity of constant magnitude I have given you the example like 40 km per hour or 50 km per hour. If the body is moving with that magnitude along a circular path, the only change in its velocity is due to the change in direction of motion. Now, as you know that velocity is a vector quantity, it has two variables. First one is magnitude, another one is direction. In this case, the magnitude of the body remains constant. That means the speed of the body remains constant, but direction of the body changes. So velocity is nothing but speed plus direction. The body has to have speed as well as direction. So the speed of the body remains constant, that is 40 km per hour, 50 km per hour, 60 km per hour, whatever it is in a circular path. But along a circular path, in each and every single point, the direction of the motion, that means the direction in which the body is moving, that changes. The motion of the body moving along a circular path is therefore an example of accelerated motion. So this can be an example of accelerated motion. What is accelerated motion? I have already explained you. We know that circumference of a circle of a radius r is given by pi to r. So it should be 2 pi r or pi to r, doesn't matter. 2 into pi into r. In mathematics, you must have covered this one. If a body takes t seconds to go once around the circular path of radius r, the speed of the body v is given by 2 pi r by t. That is, suppose this is a circular path. Here, this is the radius of the body, that is r. So what is the perimeter? Perimeter is equal to 2 pi r. So suppose the body starts its motion from this point, it has to travel along the circular path and come back to the same point. So this is the perimeter of the circle through which the body is traveling. So what is the perimeter of any circle? 2 pi r. So 2 pi r is the distance which is traveled by the body. Okay, so velocity is equal to displacement by time. So here velocity is equal to this distance which is traveled by the body divided by time. Okay, which is velocity of the body. So here you do not get confused. Sometimes I'm using distance, sometimes I'm using displacement. Both are same. Here distance is having only direction, displacement doesn't have any direction. So do not get confused here. Now, when an object moves in a circular path with uniform speed, its motion is called uniform circular motion. Now, suppose a body is moving in this circular path with uniform speed, with constant speed. So, it is also known as uniform circular motion. Uniform circular motion means in a circular path, the body is moving with same speed, constant speed. That is uniform circular motion. Okay. So hopefully I'm able to make you understand the meaning of uniform circular motion. If you have any doubt, you can ask me on the comment. Okay. So in the next video, we'll solve some of the questions. So these are some of the questions that I wanted to show you. See, these are the exercise of your NCERT book. Question number 1, 2, 3, 4, 5. You pause the video, go through the questions once, try to solve these questions on your own. In the next video, I'll be uploading answer of these questions. So pause it here. Question number 1, 2, 3, 4 up to question number 4, it can be clearly seen. You pause it here. Now, again you pause it here. This is question number 5. Pause it and write it. Try to solve this question. Then this is question number 6. This is a graph. There are 4 questions. With the help of this graph, you need to answer these 4 questions. You can note it down. Then we have question number 7, question number 8. Question number 8 is also a graph type question. With the help of this graph, we need to solve this one. Then we have question number 9 and 10. You can also pause the video here and note the question and try to solve these answers. Then this much. Okay, so in the next video I'll be uploading the answer of these questions. Before that one, you try to solve these questions on your own. Okay, thank you and have a nice day.